Hi, I'm going to be talking about using multivariate clustering to characterize ecoregion borders, a paper by William Hargrove and Forrest Hoffman. So ecoregions are areas of similar environmental conditions, and they're an important tool in many fields and professions. On the right-hand side, you can see the United States in different areas denoting different ecoregions. So historically, ecologists made subjective decisions on ecoregions and where their borders are. However, we can define objective regions based on the clustering of 9 different numerical environmental conditions. So these are the 9 that we'll be looking at today. They're things like precipitation, temperature, soil quality, and so on. So those 9 different characteristics can be depicted as 9 dimensions in a new coordinate space, which we'll call data space, instead of just geographic space. However, 9 coordinates and 9 dimensions is a bit much, so we can use principal component analysis to narrow it down to a 3-dimensional space. So by finding the first 3 principal components, as we've done here, and color-coded each one, which will be important later, we can depict each data point on this new 3-dimensional plot, which has to do with its similarity in terms of environmental factors. As you can see here, we've depicted this 3-dimensional space, and each bubble is a cluster centroid. The size of the bubble refers to the density of points within each cluster. So you can see that towards the center of the value area is a higher density, which makes sense with normal distribution of values in nature. How we implement this is we start with saying how many clusters we want. We could say K. Then we say K seed points are picked to be as far as possible within that data space, so not within the geographic space. All other points are then assigned to a cluster based on their proximity to those seed points, and this is using the Euclidean distance in data space. The average data space coordinates of each cluster becomes a new centroid for the cluster, and that centroid takes over the role of the seed. All other points are assigned to a cluster based on their proximity to that centroid point. We repeat the last 2 steps until a set minimum number of cells exchange between clusters. So we can also decide how to color this data. We can use random coloring to show, as we saw earlier, the borders between each ecoregion more clearly. But we can also use coloring that characterizes the regions based on those 9 factors. So as we saw earlier, the 3 principal components dimensions can be shown as color quantities. So the first principal component we depict in red, the second in green, the third in blue. These form unique colors because of RGB coloring. So any point in data space can be depicted with an RGB unique coloring. Darker shades denote primarily smaller values, as we can think of dimmer RGB pixels, and lighter shades denote higher values across the board, as we can think of all RGB pixels being active. We can also give map cells a value of representativeness, and we will display this as an elevation. So representativeness is a value based on how far away a data point is from the centroid within the data space. So if the centroid itself is going to be the highest peak, and the points near the edge of the cluster are going to be lower elevation, and less representative. This is important for assessing the quality of the clustering. So if you have 2 different clusters that show very mild differences in elevation between the 2 of them, it may not be as important for them to be delineated as such, and perhaps you have too many K clusters. As well, if you find a crater within a single cluster, within a single topological space like this, you perhaps need an extra space to be depicted there. Elevation points naturally lead to contour lines, which we could use to study borders between ecoregions. So they can either be stark and well defined or gradual and not obvious. So what we have here is a real-life example between Alabama, Georgia, and Florida. We have some ecoregions here in red, green, dark green, and light green. And you can see here that they're depicted by elevation. And for example, you can see these green stripes to the right-hand side of the map here. These are actually rivers originating higher up in the state. So it makes sense that they would have the same ecoregion as that area. You can see that there's sharper contrast in elevation between these areas to the top left, and there's less sharp, so less steep difference between this green and red in the bottom left. We can make these into contour lines, and you can see when the contour is spotty, it's less obvious. When the contour is dark, it's more clear that those borders exist. And of course, we can characterize the coloring, and we can also just depict it in a two-dimensional space. Thank you.